have come in that there are a number of folks on the webinar tonight who are new to Greenbelt. So welcome to the Greenbelt community. Greenbelt is your local land trust. We work with the landowners in the 34 cities and towns of Essex County to conserve open space, farmland, wildlife habitat, and scenic landscapes. Our work helps to protect native plants, animals, and natural corridors, and to ensure a healthy food supply, maintain clean water, and create free and accessible places for outdoor recreation and the enjoyment of nature. Every year, Greenbelt presents a film and lecture series as part of our outreach to engage the public with important local conservation topics. This year, our series focuses on coastal resilience and is funded by a grant from the Massachusetts Office of Coastal Zone Management. Thank you very much to CZM. During tonight's lecture, we hope you'll post your questions in the Q&A box, which is accessible using the button at the bottom of your screen. We'll address your questions at the end of the presentation. You can also post in the Q&A if you have any technical difficulties, and feel free to also use the chat function to discuss amongst yourselves and share resources. We are thrilled to present tonight's lecture, Sea Level Rise, Climate Vulnerabilities for Coastal Salt Marshes, with Dr. Danielle Perry, Mass Audubon's climate adaptation ecologist. In her position, she's evaluating the vulnerability of Mass Audubon sanctuaries to climate change effects and implementing climate adaptation projects to improve resiliency of these environments. She also works with towns, nonprofits, and other environmental agencies to preserve Massachusetts land and resources. She recently finished her PhD at the University of Rhode Island, where her research focused on salt marsh climate change adaptation. Working with coastal managers within Rhode Island, Dr. Perry helped implement and monitor salt marsh climate adaptation projects across the state. We're so pleased that Dr. Perry is joining us tonight, and welcome again, and I'll turn it over to Dr. Perry.
Thank you, Chris, for that introduction, and thank you, Greenbelt, for having me here tonight. I'll just share my screen. Okay. All right. So thank you everyone for joining tonight. As it was introduced, my name is Danielle Perry and I work for Mass Audubon as its climate adaptation ecologist. And just to speak a little bit more about the mission of Mass Audubon and some of the work that we do. So we protect more than 38,000 acres of land throughout Massachusetts, saving birds and other wildlife. We welcome more than 500,000 visitors a year to our wildlife sanctuaries that contain over 20 nature centers. We advocate on Beacon Hill to have a positive influence in environmental policy and conduct conservation research and restoration actions to preserve Massachusetts lands with my work right now focusing on coastal resilience. I'm also representative for the Plum Island Ecosystems Long-Term Ecological Research, or the PI-LTER, which some folks may be familiar with because it is located in northeastern Massachusetts. And it is an integrated research, education, and outreach program with the goal of developing an understanding of the long-term response of watershed and estuarine ecosystems to changes in climate, land use, and sea level, and using that information to protect natural coastal resources. So my presentation tonight will be broken into 4 different parts. First part, kind of having more of an introduction of what climate change is and what are some of the impacts of climate change. And I'll be focusing mainly on the sea level rise impact and focusing how, in the second part, seeing how sea level rise is impacting our salt marsh environments. And part 3 is really like the meat of the presentation, where I'll be talking about how what Mass Audubon is doing to prepare for sea level rise for its coastal properties and its salt marshes. In the last part, I'll be going into some restoration efforts that have been completed within the Great Marsh, and as well as other locations to further protect our salt marshes and help them withstand the effects of sea level rise. So the first part, what is climate change? We can often hear about this metaphor of climate change, of this heat trapping blanket. So when thinking of this metaphor, we consider the atmosphere like a blanket surrounding the Earth, and the greenhouse gas concentration within the atmosphere determines the thickness of that blanket. And as we burn fossil fuels, we're adding more greenhouse gases to that atmosphere, and greenhouse gases have the capability of trapping heat. So that heat is adding further thickness to this blanket atmosphere metaphor. And as we're burning greenhouse gases, we're continuously just adding more heat trapping elements to the atmosphere, causing this warming that we're seeing across the planet. And so the blanket is becoming too thick, the atmosphere is too thick with greenhouse gases, it's trapping too much heat, and now we're seeing these changes in climate that we're experiencing. So greenhouse gases include water vapor, carbon dioxide, methane, nitrous oxide, ozone, and some artificial chemicals such as chlorofluorocarbons or CFCs. And we often think of, when we're talking about greenhouse gases impacting climate change, we often think about carbon dioxide, methane, and nitrous oxide. And although carbon dioxide is more abundant in the atmosphere than methane, methane is a more potent and stronger greenhouse gas compared to carbon dioxide. And methane has a higher potential to trap heat and has a higher capability to do so as well. And it's considered about 28 to 36 times stronger than CO2. So even though methane is in lower concentrations, even that low concentration can have such a large effect on trapping heat within our atmosphere. And some of the main sources of atmospheric methane is agriculture, such as cattle farming, waste from landfills, and methane driven from fossil fuel burning. And nitrous oxide is even more powerful than methane. So it even has a higher capability of trapping heat within our atmosphere. So I want to go through the greenhouse effect to kind of further contextualize climate change and how this is impacting our planet. So the greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is then reflected back into space. So some of that energy is reflected back into space and leaves our atmosphere. The greenhouse effect is useful because it traps some energy, keeps the temperatures on our planet mild and suitable for living things. However, too much greenhouse gases can cause the temperature to increase out of control, causing these changes in climate that we're experiencing. So as mentioned before, some of the sun's energy is reflected back into space or being trapped within our atmosphere and absorbed by these greenhouse gases that consist of our atmosphere. The absorbed energy warms the Earth and the surface of the Earth, and this process maintains the Earth's temperature at around 33 degrees Celsius warmer than it would otherwise, allowing life to exist on Earth. So the greenhouse effect is a very important process. We need it to survive on this planet, but the issue arises when we are having too much greenhouse gases within our atmosphere and we're trapping too much heat and less heat is escaping back into space. So more heat is remaining within our atmosphere, being re-radiated back into the Earth's surface, warming the planet and causing these changes in climate. So since the Industrial Revolution, atmospheric CO2 concentration has increased by about 40% from around 280 parts per million to just above 400 parts per million, which is expressed in this graph here. So around this time, the Industrial Revolution occurred. We started pumping a lot more concentrations of CO2 into our atmosphere, which is then leading to this large spike that we're seeing post-Industrial Revolution. And before that, the concentration was lower around that 280 parts per million concentration, but now we're closer to 400 parts per million. And this figure shows natural CO2 emissions and human CO2 emissions from burning fossil fuels compared to CO2 absorption by vegetation, land, and the ocean. Numbers represent the flux of carbon dioxide in gigatons per year, and this is adapted from the Intergovernmental Panel on Climate Change, or IPCC. So natural systems do emit greenhouse gases as well, but the difference is that these natural systems also have processes to remove greenhouse gases from the atmosphere, often removing more than they emit. And human processes like fossil fuel burning do not have that balance, and so there's no additional absorption occurring to counteract the emissions that this burning is leading to or causes. And there's a number of different impacts of climate change. We're seeing warming temperatures, shifts in our seasons, also seeing increase in precipitation events, higher frequency and severity of storms. But for this presentation, I'm really going to be focusing on the impact of sea level rise. So climate change causing our sea levels to rise. So one connection that often we think about is that of the melting of our polar ice caps, melting of glaciers that are adding more water into our oceans, causing them to rise, as well as the ocean is warming, it's also expanding. So as it warms, it's taking up more space, also leading to our sea levels to rise. So these are all sub-causes under the big umbrella of climate change being the major cause of sea level rise. So this was the first part. So then I'll go into our second part, but first wanted to take any questions if folks had questions on part one.
So there's a comment. Someone says, how about talking about greenhouse gases going wild as in on the planet Venus? Maybe an extreme example.
So unlike Venus, because we have that greenhouse gas effect, we're able to be able to have suitable temperatures within our planet, but Venus doesn't have that to help it. So with it having an exorbitant amount of greenhouse gases within Venus, and so it's leading to the much higher temperatures within that location. That's a good point.
How cool. That's the only question so far, and I just want to remind folks that the Q&A box is there, so please feel free to enter your questions at any time, and we'll get to them after each section.
All right. So moving on to part two, so looking at sea level rise and their impacts on salt marshes. But first, I want to talk about overall salt marsh importance. So salt marshes are a type of marine ecosystem. They can serve as a buffer system between our terrestrial and our marine environments. And they help to trap nutrients that come from runoff from our coastal developments and prevent those nutrients from entering our water bodies. So they also help to reduce flooding, especially when we are seeing our storms, and helps to reduce the amount of flooding that can stem from storms, because salt marshes are able to act as a sponge to kind of absorb that water that would otherwise be coming into our coastal developed areas, flooding our roads, flooding our buildings. So it helps prevent and mitigate that response. And it's also able to mitigate wave action. So it decreases the energy of waves, again, protecting a lot of our coastal development. It's also an important resource for fisheries and birds. So a majority of the aquaculture species uses at least part of their life cycle within the salt marsh environment. And these species are using it for refuge, for food, for nursery ground. And this is the same for bird species as well, which rely on salt marshes often for food, as well as for nursery and nesting purposes. It's also an important carbon sink because this area is very productive. There's a plethora of plants that remove CO2 from the atmosphere. And also there's carbon being stored within the sediment of salt marsh environments. And because salt marshes are marine and they spend a lot of their time being inundated, decomposition within these ecosystems is very slow. So unlike forested environments where decomposition is faster because oxygen is more readily available, within salt marshes, because decomposition is so slow, it's able to store a lot of carbon, especially within the soil, as well as be able to remove carbon dioxide from the atmosphere, which then helps to be an important factor for mitigating some of these climate change effects and slowing down, and has the potential to slow down the effects of climate change as well. So sea level rise is a major threat to salt marshes, and this is particularly true for those marshes within New England, because New England is facing rates of sea level rise about 3 to 4 times the global average. And some of the impacts that we're seeing our salt marshes having to endure is changes in vegetation composition, especially within the high marsh area, where we're seeing that high marsh plants are actually being displaced by low marsh plants, because high marsh plants aren't able to withstand the constant flooding or the increased flooding that is occurring with sea level rise. And while low marsh plants, they are more accustomed to withstand that more consistent flooding. So we're starting to lose our high marsh habitat because they can't withstand that stress, and we're gaining more low marsh plant habitat. And this is a cause for concern because there's certain species that really rely on high marsh plants and that high marsh habitat, especially our salt marsh sparrow that nests within the high marsh. And so losing that habitat can be really devastating for certain bird species as well as other wildlife. There's also an increase in vegetation die-off areas, as you can see from the pictures. We're seeing more ponding occurring, water that's not being drained during low tide, that's more resting on the marsh surface. And this is causing marsh degradation. So we're seeing that the ponds are then dying off the vegetation. We're seeing more stunted vegetation within these areas. And now we're seeing an expansion of bare areas on the marsh. So one response that salt marshes have is to move landward, so to complete salt marsh migration. But especially within New England, because our coastal areas are so developed, there's often many barriers for salt marshes to do this. So salt marshes are not able to move backwards or to have landward retreat because of the coastal development, because of roads, because of buildings. And so they're not able to naturally respond to sea level rise as they would. So what's happening is that our marshes now are virtually drowning in place, where they're kind of being squeezed from both ends. That sea level rise is coming in one direction, it's being blocked by coastal development on the other direction. So it's really being squeezed, and we're starting to see us losing more of our marshes, and our marshes really drowning. And as I mentioned before, although salt marshes do represent a lower total land area compared to some of our other forested environments, it does have a higher potential to store carbon and to bury carbon compared to our forested environments. So that's why there's such an important solution to climate change and helping to slow down the progression of climate change, because it does have that capability of storing carbon and preventing it from being released back into the atmosphere, which then can lead to further progression of climate change. Does anyone have any questions?
There's some great questions. Why do some regions like New England that you mentioned have higher sea level rise rates than others?
Yeah, so within New England, we are consistent of a little bit more low-lying areas compared to some areas of the rest of the country, and also actions like creation of dams, which helps to limit the amount of sediment that can reach our salt marshes. Because another way for salt marshes to respond to sea level rise is being able to accrete or grow vertically. And they grow vertically by either having sediment being added to the salt marsh. So within New England, our marshes are usually sediment deprived. And a lot of the times that when marshes are able to accrete, they rely on organic material, often from previous debris from the salt marsh material that's being added to the sediment to help it to accrete. But since they're a little bit more sediment starved, so they're not getting extra sediment from other locations, another reason of why they're not able to grow at a rate to withstand the sea level rise rate.
Thank you. Another question here is, why do salt marshes sequester so much carbon relative to other ecosystems? And along with that, someone else asked, can you explain what you mean by carbon burial?
Sure. So because salt marshes are marine ecosystems, so they spend a lot of their time with the tides being underwater. So with the tides, the plants are often buried underwater, and then as the tides recedes, are more exposed. And so the soil spends a lot of its time being wet. And when things are wet, they decompose a lot slower. So with decomposition, one of the byproducts of decomposition is carbon dioxide and methane. So because decomposition is so slow within these environments, then the CO2 and the methane isn't being produced at the same rate as other ecosystems that have oxygen readily available. So when there's more oxygen present, decomposition is a lot faster. So there's less oxygen present within salt marshes because they're wet most of the time. So that means decomposition is a lot slower. So there's less release of that greenhouse gases that result from decomposition. And then what was it, part two?
Oh, it was, I think that you answered it. Why are they so much better at sequestering carbon?
Okay, great.
Yeah, yep. This person says, would terraced hills be helpful or an impediment toward the salt marsh moving landward?
What was that first part?
She's suggesting that maybe some sort of terraced land warming. She says terraced hills would be possibly helpful on the landward side of marshes.
Oh, I'm not quite familiar with the terrace hills. Is that I don't know if that's a project or a type of.
I think she's just suggesting to leave some open space that's gradually higher and higher.
Yep. So definitely being able to even create buffer zones. We already have buffer zones in place, but sometimes for one reason or another, we would want to even expand those buffer zones even further to enable to give space to marshes. But sometimes that can even be encroached upon. So being able to provide as much space as possible surrounding our marshes could be very beneficial.
Mm-hmm. Let's see here. This person asks if you could talk a little bit about whether the marshes in the Great Marsh are also rising along with sea level rise. Is the marsh level rising?
Yeah, so they are accreting, but unfortunately the accretion rate of the marshes, so the rate that the marshes are growing is not fast enough to keep up with sea level rise. So that's another location where sea level rise is outpacing the growth of marshes.
And what role is played by freshwater rivers or briny creeks that open up into marshes?
So say that one more time?
Yep, this person's asking what role that freshwater rivers or briny creeks play, the ones that open up through the marshes. Do they have a role in helping with sequestration or sea level rise or any of the effects you've talked about?
Yeah, so freshwater marshes, especially if they're bordering salt marsh environments, they can eventually become salt marshes because salt marshes can potentially migrate into those freshwater habitats, and then they can eventually be adapted to salt marshes. So they could be a nice migration zone. But then again, concerning too, because we don't want to lose our freshwater habitats because they serve as an importance. So it's kind of like a double-edged sword there. So being able to open up barriers, especially man-made barriers, of removing them is often our safest bet because then we're not also losing other natural ecosystems.
Let's see. I think people are saying I was hard to hear. Sorry. So this person mentions that for thousands of years, New England's land was depressed by glaciers, and now the land itself is rising. Does this have any effect on the marsh level rising at all?
So I can currently sea level, the marshes just aren't growing at the rate to keep up with sea level rise. So even if like the current rate, if the lands are rising, the salt marshes still aren't being able to keep pace under its current growth rates since sea level rise has just been so accelerated and so rapid within this area.
Great. I think we'll just do one more and then I'll let you continue. Okay. Does the abundance of Phragmites have an effect on the resilience of salt marshes?
Mhm. So Phragmites, they're an invasive species. So they actually can also act as a barrier for salt marsh migration because they're outcompeting some of the natural plants within this ecosystem. So they can hinder the resilience of marshes and prevent landward migration, as well as displace native species. So they can be an issue within salt marshes. Okay, great questions. So now I'll talk more about what Mass Audubon is doing with their climate vulnerability assessments to help prepare lands to sea level rise impacts. So we've completed pilot vulnerability assessments for 5 of our coastal sites, and that being Joppa Flats in Newburyport, Rough Meadows in Raleigh, Eastern Point in Gloucester, Barnstable Great Marsh in Barnstable, and Wellfleet Bay in Wellfleet. And so I'm going to be focusing on our North Shore sites within Essex County of Joppa Flats and Rough Meadows, as well as Eastern Point for this presentation. But we also did 2 pilot sites within the Cape Cod at Wellfleet and at Barnstable. But like I said, for this presentation, I'll be focusing on our Essex County marshes at Joppa Flats, Rough Meadows, and Eastern Point. So our climate vulnerability assessments were broken up into 3 separate parts. Our first part was being able to prioritize each of the different assets within resources at each of our sanctuaries and giving them values based off of their importance for Mass Audubon purposes, for ecological reasons, as well as for visitor experience. And the second part was our sea level rise assessment. And this was more looking at future projections of sea level rise and using modeling like the sea level affecting marshes model or SLAM modeling to then determine how our habitats are expected to change with different levels, scenarios of sea level rise that we expect. And also using NOAA sea level rise data to inform that analysis as well. And also determining what resources are expected to be flooded during these different timeframes. And also using field surveys to get a better understanding of what our current condition of marshes are to then determine how resilient they are to future sea level rise impacts. So the first part, it was prioritizing our Mass Audubon resources at each of those different sanctuaries. And this was done using a resource prioritization survey. So we built off a survey that the trustees of reservations use for their climate vulnerability assessments, and we made some adjustments for Mass Audubon purposes. So this survey is broken up into 6 different categories or 6 different criterias. And to get a closer look at what the survey looked like is, like I mentioned before, we had our 6 overarching criteria and then these subcategories. And so the subcategories were, each of those resources were ranked using that each subcategory from a scale of 0 to 5, 0 being no value, 1 being a slight value, 3 a moderate value, and then 5 a high value. And the maximum score for each of the resources was 50. So each resource is using this survey and then using each of these sub-criteria as being ranked of its overall value. And to provide an example, some examples of the resources that we scored, we would score our trail systems, observation decks, visitor centers, our natural habitats as well. And then the results of that survey would then give us a resource value for that particular resource and that particular asset. So our second portion of the vulnerability assessments is then looking at the sea level rise analysis under these different sea level rise scenarios. So we focus on the intermediate high sea level rise scenario for 2030 and 2050. And so the results of this analysis was obtaining an impact of sea level rise score for a particular property. And this impact of sea level rise score consisted of 2 different scores. It consisted of a habitat score, which measured the percent change in habitat. So percent change expected from 2020 to 2030 or 2020 to 2050 of a habitat like a forest or a salt marsh. And then multiplying it by that resource value score that we obtained through that resource prioritization survey. And then we would also have a feature score, and the feature score focused more on the man-made structures. And we determined for those years as 2030 and 2050, if that resource of that man-made structure was expected to be flooded. And if it was expected to be flooded, it would receive a negative resource value score. And so the impact of sea level rise score is then the sum of all the habitat scores for that particular sanctuary and the sum of the feature scores for that wildlife sanctuary. And I'm going to go through an example just to help to contextualize some of these formulas. So I'll use Joppa Flats as an example. So the natural habitats within Joppa Flats are salt marsh and tidal flats. So in 2030, we're expected to, from 2020 to 2030, we're expected to lose about 6.4% of our salt marsh. And the salt marsh had a resource value score that we determined by going through that survey of 27. And so we multiplied 27 times 0.064, negative 0.064, to represent this loss of salt marsh that we're seeing for the habitat score of negative 1.7. And we would use the same calculation for tidal flats. We expected to gain 3% tidal flats from 2020 to 2030. And so then we would multiply 0.03 by 31, which was the calculated resource value, to get a habitat score for tidal flat of 0.9. And for our infrastructure, it shows that the road that is bordering Joppa Flats is expected to be irregularly flooded by 2030. And since it's only irregularly flooded, it would only lose half of its resource value score to be negative 14.5, because its total value score is 29. So if it was to be regularly flooded, it would lose the full negative 29 points for its resource value. So now for the impact of sea level rise score, we would sum up all of the habitat scores. So the habitat score for the salt marsh, for the tidal flat, as well as the feature score, to then get this overall impact of sea level rise score for that wildlife sanctuary. So for Joppa Flats for 2030, it comes out to be about negative 15.3. And then for the last part of our vulnerability assessment work is actually doing field surveys within our salt marsh environments to get a better idea of its current conditions, to help us understand its overall resiliency and vulnerability as sea level rise progresses. So these methods were based off of a Rhode Island marsh rapid assessment method, and the survey is broken into 3 different parts. So for the first part is calculating its resilience score of the salt marsh. And we did this by looking at the disturbances on site. So we looked at disturbances like nutrient inputs within the salt marsh environment, as well as ponding and plant die-offs that is already occurring on the salt marsh platform, ditching within the area, as well as invasive species present like Phragmites. So the higher the disturbances within our salt marshes would lead to a lower resilience score. And then the second part of the field surveys was then calculating a salt marsh condition score, which had a max value of 10. So, and we did this by looking at the vegetation communities present within our salt marshes, which really lets us know current conditions of our marshes, what are some of the responses that we're already seeing due to sea level rise. And so the higher the habitat quality, we would get a higher salt marsh condition score, and the poorer the habitat quality, we would get a lower salt marsh condition score. And then the last part was looking at migration potential. As I mentioned before, naturally salt marshes would respond to sea level rise by moving landward. And so being able to attest whether or not they have potential to do that by looking at the surrounding habitats, whether it's natural areas that surrounds the salt marshes, whether it's urban or residential areas, will give us an idea of how resilient these marshes to be able to handle sea level rise just by that natural process of moving backwards. So now I'll just go through the results for each of our sites within Essex County. So first being Rough Meadows. So Rough Meadows showed to have a moderate resilience score. So as I mentioned before, a resilience score we calculated by looking at the disturbances on site. So some of the disturbances within Rough Meadows was the ditching the historic ditching within the area, within the salt marsh, as well as the ponding and die-off depressions that are already present within rough meadows, and the invasive species, Phragmites, being present there. And it had a salt marsh condition score of 7.5 out of 10. And some of the negatives that lowered its score was, again, those die-off bare depressions. We're seeing some displacement of high marsh plant species by low marsh plant species. As I mentioned before, with sea level rise, our low marsh is kind of crouching in on the high marsh habitat and displacing that the high marsh plants that reside within that area. And also it having Phragmites present, which is an invasive species. And some positives is that we're seeing on the marsh, it does have extensive high marsh area. It also has salt shrubs within the area and natural pans. And so we use the impact of sea level rise score to then prioritize our sites. So based off of this impact of sea level rise score, this site compared to the other two sites was ranked as the third prioritization. So our other two sites, based off of their impact of sea level rise score, showed to need more attention compared to our rough meadow site. So that's why it ranked third for prioritization for this particular list. And so for 2030, we're seeing an impact of sea level rise score of negative 22.5. And that is mostly because habitat score is negative because we're starting to lose some of our forested environments because we are seeing salt marsh migration. The salt marshes are being able to move backwards into the forested environments and displacing some of the forested areas. And our feature score it being negative because some of our trails were being irregularly flooded, as well as the roads within the rough meadows being irregularly flooded as well. And by 2050, we start seeing a positive habitat score because we're starting to gain more forested wetland. And we're seeing an increase in our feature score because the roads are now becoming regularly flooded instead of irregularly flooded by 2050. But as I mentioned before, this area does have a high migration potential. So there is chance for the salt marsh to be able to still keep its land area because it's being able to move backwards into these other natural habitats. And then based off of these results, some of the action items that we are recommending for rough meadows is wanting to further enhance salt marsh resilience by restoring some of those die-off areas by using hydrological restoration, draining some of those water impoundments by using a technique called runneling. And I'll talk about runneling at the end of the presentation in part 4. And also using ditch remediation. So where appropriate, filling in some of those historic ditches with like natural salt marsh material to then prevent some of the negative responses that are occurring because of extensive ditching within the site. And also wanting to collaborate with our towns and our partners in order to enhance the resiliency and protect some of our roads that are expected to be flooded under these different scenarios using nature-based solutions. So the second site that I'll talk about is Joppa Flats. This is in Newburyport. So Joppa Flats showed to have a low resilience compared to taking into account the amount of disturbances at this site. So this site did show to have high disturbances. It had buffer encroachment. There's a road lining the salt marsh along the Joppa Flats Wildlife Sanctuary that is preventing any salt marsh migration, which then attenuates to it also having a low migration potential. There's ponding and die-off depressions within Joppa Flats. So the salt marsh platform itself is already showing degradation, soil disturbance. There's invasive species present, Phragmites is there, as well as influence from human nutrient inputs. And it also has a lower salt marsh condition score. So as mentioning before, that we're already seeing a degrading salt marsh platform within the site. There's die-off bare depressions. We're seeing that displacement of high marsh plant species by low marsh plant species and invasive species presence. But some positives within this site is that it does have a distinctive low marsh area, and it does still have the presence of brackish marsh natives within this site, which is often one of the first species to go with sea level rise because they're not as tolerant to salt inundation. And then based off of our impact of sea level rise score, this site was prioritized as the second out of the three to want to require our action. So for the salt marsh, it's expected to lose about 6% of its marsh in 2030, but from 2020 to 2030, we're expected to lose about 6% of the salt marsh. And the tidal flat, we're expected to gain 3%, which is representing that habitat score that we're seeing for 2030. And then for our feature score for both 2030 and 2050, it's just that the Plum Island Turnpike that's bordering the salt marsh is expected to be irregularly flooded for both of those years. And now for a habitat score for 2050, we're actually losing more of our salt marsh, and we're starting to lose tidal flat. So losing about 21% of our salt marsh from 2020 to 2050, and then losing about 23% of our tidal flat from 2020 to 2050, which is encompassing those impact of sea level rise scores. So some action items is wanting to collect more data at the site to really see what is causing this rapid degradation of marsh habitat. We feel that it's something other than just sea level rise that's causing this degradation. And we think that nutrients is playing a large impact because it is closer to a wastewater treatment plant. So there's opportunity for nutrients to run into the marsh and help and further degrade the marsh system. So wanting to collect more data on the nutrient concentration within the soil to see if that's playing a role. And we also wanting to explore living shorelines within this area to help mitigate the wave action, to help slow down those impacts of sea level rise and to be able to protect and slow down the rate of loss of salt marshes, especially within this location. And then the last site is Eastern Point in Gloucester. So Eastern Point showed to have a low to moderate resilience score, and the disturbances within this location was anthropogenic nutrient inputs, seeing some ponding and die-off depression within the marsh, and also buffer encroachment. So this is another location where a road is bordering the marsh, so limiting migration. And unlike Joppa, this area is also connected to other natural habitats. So instead of having just a low migration potential, it's kind of borderline between low and moderate, because there are other freshwater ecosystems next to the salt marsh that it's possible for the salt marsh to migrate into. So it's highering its migration potential due to that fact. But this location did have a higher salt marsh condition score compared to the other two locations. But it is also good to consider that this marsh is considerably smaller than Rough Meadows and the Marsh of Joppa Flats. And some negatives that lowered the salt marsh condition score for this particular site was the presence of invasive species. And a positive was that it does have extensive high marsh area. And then this site was actually prioritized to be #1 for action because of really the feature score driving the higher impact of sea level rise score, or the more negatives representing to be more expected to be influenced by sea level rise for both the years of 2030 and 2050. And so for 2030, we're seeing a majority of loss in habitat for 2030. And by 2050, we see a positive habitat score because we're starting to gain forested and non-forested wetlands. But when we look at our feature score for 2030, we are seeing the road that's only entry point into the wildlife sanctuary is expected to be regularly flooded by the time of 2030. And then also our trails are being irregularly flooded during that time frame. And by 2050, that road is now becoming regularly flooded, which you can see in that increase in the feature score. And now the parking lot also is being regularly flooded by 2050 as well. So because of the parking lot and the road having such high resource values, because it's really important, especially for visitor experience, it kind of showed to have a higher or a more significant or more negative impact of sea level rise score, meaning that it's being more impacted by sea level rise, considering these important resources. And so some action items for this site is wanting to use climate adaptation for infrastructure. So either creating a living shoreline to further protect the road, protect the parking lot, to again, slow down some of those sea level rise impacts. And also within our marsh, wanting to use some ditch maintenance to help to drain some of the water impoundments that we're seeing on the marsh to help promote revegetation. So if we're comparing all the sites against each other, and we look at the impact of sea level rise score, we can see clearly that Eastern Point is having a more negative, so a more impacted by sea level rise compared to the other two sites. And even though Rough Meadows showed to have a more negative, so more highly impacted by sea level rise score compared to Joppa Flats, because Rough Meadows is currently in better conditions compared to Joppa Flats, as well as having a high migration potential where Joppa Flats has a lower migration potential, we would prioritize Joppa Flats above Rough Meadows because Rough Meadows is a little bit more equipped and more resilient for future sea level rise impacts, being compared to its current conditions. And Joppa Flats is in a bit worse conditions compared to that site. So wanting to then prioritize the area that is more vulnerable to further progression of sea level rise. And then I'll take any questions for that part, for part 3.
There are a bunch of questions, really good questions. Hang on here. Okay, hopefully this is some better audio. Let me know, guys, in the Q&A if you still can't understand me. So we have a bunch of questions about what is a living shoreline. Can you talk about that a little bit?
Yeah, so living shorelines, they use natural plants. They use really relying on natural systems to help mitigate some of these impacts. So for an example, like a living shoreline can even itself be a salt marsh or also planting planting different salt marsh vegetation, because that can help to slow down the use or slow down let's say wave action. So slow down that wave action that can help to increase erosion. And also people often you can use reef balls. Like reef balls are kind of like this concrete structure that you can put out into along to border the coast, and that can also help to slow down wave action to help decrease erosion that is reaching our marshes. So they're kind of more of like green infrastructure to use to help mitigate some of these climate change and sea level rise effects.
Great. Yeah, and along those lines, someone else suggested that maybe a permeable surface in that parking lot at Eastern Point would be helpful.
Yes, that's a great suggestion. Mm-hmm.
Gosh, so many good questions here. So talking about marsh migration, several questions on that topic. How does the topography around the marsh affect that? And this other person asks, how long, if scientists can actually predict this, how long does it take for a marsh to migrate?
Okay, so for the first question, so topography, it plays a very important role. So for our additional site that we did at Wellfleet Bay, is that the area, although it's surrounded by natural ecosystems, it has a steep slope. So areas that have a steep slope or a steep topography, you're not going to see as efficient of salt marsh migration, because it's a little bit too much of a leap for the salt marshes to move backwards, because it has to overcome that very steep barrier of migration. So more shallow slopes are better for migration. And so that's how topography can really play an important role. And then for the second, what was the second part?
The second part is, how long does it take for a marsh to migrate?
So this is a long process. So this isn't something that will happen within the next couple of years. We will start seeing signs of salt marsh migration within like a year's time frame. We can start seeing salt marsh, high marsh being moved into the forest environment. So we might start seeing salt marsh grasses on the sediment within forests. We might start seeing trees starting to die off. So, but it is a slow process, and so it does take some time. But there are little signs that we can periodically see and start to monitor over time.
As far as all of the different salt marsh flora. Well, we have a question about what are salt shrubs, but can you talk a little bit about, in general, what kinds of plants we're seeing here?
Yeah, sure. So I'll start in the low marsh. So in the low part of the salt marsh, we often, the predominant species, at least within New England salt marshes, is something called cordgrass. So that's a predominant low marsh plant species. And then within the high marsh, we're seeing a lot of like salt marsh hay, salt marsh meadow. And that kind of resembles, like, again, like its name, more berry hay-like. It gives it that meadow feel. It kind of looks a little fluffy. And so what's happening in the cordgrass, it kind of resembles a little bit more, it's of like the grass, like it stands up erect. It's a little bit more stocky, versus in the high marsh, the salt marsh hay, it lies down flat. It's a little bit more like bushy, a bushy look to it. And so what's happening is that the cordgrass in the low marsh is actually taking up that high marsh, salt marsh hay space. And so salt marsh shrubs is even considered in the upland of the salt marsh, where it's just like more of this like woody material. So like woody brush is more representing of the salt marsh shrubs.
Gotcha, thank you. And another person asked, speaking of salt marsh hay, does the commercial harvesting of marsh hay harm the salt marshes?
So it depends on the extent in which it's being done. So, and then that's one of the techniques that we're also using for some ditch remediation, which I'm going to talk about in the last section. So it depends on how frequent that the mowing is occurring, because we want to make sure that once we're mowing, we're still giving the marsh enough time to be able to grow back and replenish itself after mowing. So it's important to have maintenance when you're doing that. You're not doing it too frequently. That can actually lead to erosion of the marsh.
That makes sense. And does it help at all for humans to start planting some of those grasses higher up to help the migration of the marsh?
So, because sometimes we can do it too early, because especially if we're doing it within the forested environments, because very quickly the forest can be like, can kind of like push that out and it not being suitable, because oftentimes it can happen naturally. And so, but one thing is that, especially when we're working with our towns, is that wanting to just remove barriers. So I like it when the natural ecosystem can kind of take care of itself and being able to control that process and move on its suitable timeline. But what we can do, especially when working with the towns, is being able to remove unnecessary barriers to migration, and so that marshes can easily move backwards once those barriers are removed.
That makes sense. Great. There are a few more questions, but I don't know if you want to keep sharing and we'll come back to them.
Yeah, sounds good. Okay, so we're at our last part, and then I'm sure there'll be more time for questions at the end as well. So the last part of this presentation is then talking about climate adaptation projects that have currently being done and have been done in the past to enhance the resiliency of our salt marshes. So climate change adaptation is a type of management action that is used to help natural ecosystems cope with, respond to, and prepare for different climate change effects, such as sea level rise. So one type of climate change adaptation strategy is hydrological restoration, or the use of dredged runnels. And runnels is just a very shallow channel. It can be about like 1/2 meter in width and length. It can be even less than that, to just be a few centimeters in width and length. And these runnels are used to drain water impoundment. So as I mentioned in the beginning of the presentation, one of the impacts of sea level rise is that we're seeing more pools of water resting on our salt marsh that aren't being drained. And these pools are causing flooding stress especially for our high marsh areas that aren't able to withstand this constant inundation of water. So the purpose of these runnels is to then drain these pools, to drain these water impoundments, to alleviate some of that flooding stress, to give a chance for our plants to revegetate those bare areas that were taken over by those water pools. And so as you can see from the pictures, that runnels can be either hand dug, they can also be dug with an excavator. And U.S. Fish and Wildlife Service is implementing a runnel project at its Parker River National Wildlife Refuge in Newburyport. Mass Audubon is implementing a runnel project at Allen's Pond Wildlife Sanctuary in Dartmouth. And the Buzzards Bay Coalition is implementing runnels throughout Buzzards Bay marshes as well. And just to kind of show, give a better picture of how our runnels are working. So this is an example of a Rhode Island marsh in Westerly. And this is, the top image is of the area before the runnels were instituted. And this is just showing the creation using an excavator. And this is about 4 years after the runnels were created. And now we're seeing that there's a lot more revegetation due to that excess drainage. So showing that that drainage effect really does aid in for plants to recolony and to alleviate some of that flooding stress that these habitats are under. And then another climate change adaptation strategy is ditch remediation. And ditch remediation is using natural materials on the marsh. So using salt marsh hay, as I was describing before, that is being mowed on the marsh, and then, or cut on the marsh, and then using that material to fill historic ditches that have been used previously for mosquito abatement or for agricultural purposes that have been used for those purposes in the past. But with having marshes with too extensive of ditching occurring, it's actually leading to negative implications on the marsh, and allowing for the marsh to subsidence to occur on the marsh. The marsh is actually lowering in elevation. What we really wanted to do is to higher in elevation. So where it's appropriate, wanting to fill some of these ditches to prevent the lowering of the marsh that makes it even more vulnerable to sea level rise. So as you can see from these pictures, this just shows, this is a project in Nelson's Island in Raleigh. And so this is just the first year of adding the salt marsh hay into the ditches to fill it, the second year and the third year. So you can kind of see it just naturally filling, using that material to naturally fill the ditch, to then heighten the elevation capital of the marsh. And these are just examples of what a ditch would look like normally if it's not being filled. And so the trustees of reservation have completed or in the middle of monitoring a ditch remediation project within the Old Town Hill site in Newbury. The U.S. Fish and Wildlife Service, as well as the University of New Hampshire, has done a ditch remediation project in Nelson's Island in Raleigh. And then Mass Audubon is exploring this option for Rough Meadows as well. And then the last climate adaptation that I'll be sharing with you is sediment enhancement. So this has been more popular in Rhode Island than it has been in Massachusetts. And it's been done at a number of different locations within Rhode Island already. And so for sediment enhancement, what we're doing for this process, we're actually adding sediment to the marsh, dredge material, often from nearby channels, adding that sediment to the marsh to raise its elevation, to give it more time when it comes to sea level rise. This process has is a little bit more extensive than the other process that I was mentioning before, actually a lot more extensive than the other processes, and also very expensive. So this is often the last resort. This is for marshes that there are no other options, that we're really seeing these negative implications of sea level rise, and their marshes are really suffering from drowning in place and from these pools and water impoundments. So what we're actually doing is then covering the previous marsh with sediment, and then going in later and adding and planting salt marsh plants within those areas to then spark revegetation. To just kind of show some images of what this looks like. So the first image is what the marsh would look like. And I say marsh loosely at this point, because once it's covered with sediment. So right after sediment enhancement and the dredge material is spread out across the marsh, the previous marsh is then covered. And then it kind of looks like a moonscape initially of just the sand covering the marsh. And then this is just what one of the sites look like in Rhode Island after 1 year of the sediment placement, is where volunteers actually went in and did some initial plantings to help to spark revegetation. And then nature takes its course, and then 3 years down the 3 years after, this is another one of the sediment enhancement sites within Rhode Island at Ninigret Pond in Charlestown. It's starting to resemble a little bit more of a natural marsh system. So being able to closely monitor these projects to make sure that vegetation is being introduced initially and that it's recovering over time. And it is showing some positive results, at least for this project, where after 3 growing season, we are seeing a lot more vegetation from that initial photograph of it being pretty